proposal presentation or proposal preparing for ethics or your master or PhD. But it is very important. Okay. Sometimes all of your proposal is 100% okay, but just in one slide about sample size calculation that you are not specifically write it properly, then you have to you are being asking about that. Okay. So actually my lectures for those who are my undergraduate, so maybe quite same. So this is just your refresh lectures, but after this maybe I can share with you to do the GD power, because some of your research is very complicated. You cannot use any formula. This formula may be for descriptive, for simple, compare two means, two proportions. But if you have more group, you have more repeated measures groups, you have compare more than two groups, then it will be hard to use formula. So you have to use G power. Okay. Alright, for the objective, we have two types of calculation. One is for unknown population, another one is for known populations. Unknown population is like when you want to study about obesity, okay, in Malaysia. So the populations in Malaysia for obesity, maybe you cannot get the real number, because the number that you get from the government maybe not cover everybody. So, but for known populations, this is like if you want to study in a specific population, for example, in University Kebangsaan Malaysia, among Faculty of Health Science students. So you know that population is around what 1,000 or 2,000. You know that populations. So this is for known population. This is for unknown population. Okay. Oh, before that, can we record? Okay. I record. Okay. Alamak, macam mana nak record ni? Dah. Can somebody record for me?
It's already recording started.
Oh, ya ke? Okay. Okay, somebody record. Okay, thank you. Alright. Okay. The analogy of sample size calculation is like when you want to dig for a treasure on a desert. Okay, there's two possibilities. One, there is a treasure versus there is no treasure at all. So there's two possibilities. Okay, however, you are only able to make a judgment about whether the treasure is there or not based on the result of your dig. Okay, then only you can say that if you find nothing, it doesn't mean treasure is not there. But maybe you have not found it yet. Because your digging style is not make you found that treasures. Okay. Alright, so the power of digging. Okay, consider you want to dig on the island for an afternoon with a bucket and spade only. Okay, so if you find a treasure chest, then that's great. You are lucky. By using only this alat, these instruments. Okay, if you find it, then you're lucky. But if you don't find it, might be the equipment is not adequate for the job. So now you contrast this bucket and spade with mechanical excavator. So you change the instruments that can shift tons of earth in an afternoon. Here the chances of finding the treasure is much greater. And if you can't find the treasure, you can be more confident that the treasure is not there. After you are using this mechanical excavator. Okay, so the power in statistic is called beta. So in statistic, the more power, the more that you can sure that there is a treasure or there's a significance in your studies. Okay, so many researchers undertake statistical tests without knowing the power of their test, which may not be up to the job. So power is 1 minus beta. Okay, so power is influenced by sample size and effect size. Okay, sample size and effect size. The more sample size, the more your power. The more effect size also increase your power. Okay. Now, that is about the power. Okay, now about sample size analogy. Okay, if we have a lot of people digging, then we have a greater chance of finding the treasure than when we have only few. Okay, just imagine you ask 1,000 people searching, compare only 2 people searching. So the larger the size, the more powerful the test. Okay, also, the larger the effect size, okay, effect size is different. For example, the difference between the population means, the more likely we find the treasure. Okay, effect size is like, for example, if your treasure chest is size of matchbox, so you might not detect it even with our mechanical excavator. If your effect size is very small, size of matchbox. However, if it is the size of a house, we are much more likely to find it. If your effect size is big, very big, you don't need more samples. You need only a few samples. There is one simple example. You have cats in your house. Do you have cats? Anybody have cat?
I have one.
Yeah. Okay. How many legs they have?
4.
4. Okay, 4. Anybody have three legs for cat? 2? Everybody have 4, right? Cat have 4 legs. Okay. So, for me to say that, okay, cats have 4 legs, I only need maybe 5, maybe 10 to say that, okay, cats have 4 legs. I don't need 100 cats. I have to catch all 100 cats or all 1,000 cats to say that the cats have 4 legs. So that means, okay, that is very large effect size. So I don't need many. I need only few. Okay. All right. Okay, the approach of this calculation is, okay, how many samples will I need to produce a result with a certain level of confidence? Okay, now they have level of confidence. Okay, so I'm confident that by taking only 5 cats, I will sure that I will say that the cat have 4 legs. In here you have the level of confidence. Okay. Alright, so the strategies is number 1, maybe you can use census for small populations. Because census.
Hi, Doctor.
Yeah.
Doctor, sorry, can you see a small box on the slide?
Small box. Yeah.
Because it is kind of blocking the slide. Can you please minimize the box, Doctor?
Oh, nak letak kat mana? Buang
ada satu button minimize tu. Dash.
Okay. Dia pun block saya lah. Okay. Yeah. Thank you. Dia pun tak block saya. Okay. Alright, so thank you, yeah. So the strategy is, okay, number 1 is census. Census is like nowadays that we are doing bancian for our countries. That one is census, so bancian. Okay, so we take everybody. But so this census eliminates sampling error and provides data on all individuals in the population. But this is very hard for you to do research. This is not possible. Okay. Number 2, uses sample size of similar study. Okay, this one you have to be careful because if that study are making errors, so you have the risk of repeat the errors, the same errors. So no, this one cannot. Okay. The number 3, yes, you have to use formula to calculate your own sample size. You have to use apps, formulas or any apps to calculate your sample size. Okay. Okay. Pitfalls for study having smaller sample size. Okay. If you have small sample size, leads to p-value being higher and confidence interval wider. So you thereby conclude no difference between groups. Yeah? If you have very small sample size. The undersized study can be a waste of resources because it is incapable of producing useful study. You have done a lot of works, but then you cannot find any difference because of small sample size. Absence of evidence is not evidence of absence. There is a one. If you saw the mana kejap. Alah, tak jumpa lah pula. Never mind lah. This word is same like what the in the Pirate of Caribbean's movie between who? Never mind lah. Okay, there's also like they say about this. Okay, the larger the necessary. Okay, this one, if you say that, alah doctor, I just collect 1,000. It is very, very easy for me. In my country, to take 1,000 samples is very easy. Oh no, you cannot do that. You cannot larger than necessary sample size. Okay, because we don't want to to protect some subjects from unnecessarily having to endure treatments, especially those that might have unwanted or grievous outcomes. Larger than necessary can put people in jeopardy unnecessarily. If you say, my research is very simple. I have questionnaires, but if your questionnaires, you have 5 questionnaires. One is stress level, another one is coping scale, another one is time management, another one is quality of life. 5, when the samples need to provide 2 hours to answer that questionnaire and put themselves in very stress levels. So you might not do that. So you have to choose correctly. If you need only 200, okay, just 200 people. Don't take another 2,000 people. Okay. This one, delta. Okay, delta. This is a minimum worthwhile difference. Okay. This is based on clinical importance, not a statistical ground. This is decided by you as a researcher. Okay. So you can be assume that the smallest difference that is assumed as the most significant clinically, maybe between 5 to 15% difference. Okay, the researcher must give the justification for choosing the delta value. Okay, this error can also be interpreted as margin of error between sample mean and population mean. Okay, you have taken your sample. Okay, if you have before you taking your sample, you have your own study, your own research. Okay, the population is this value. So what you want to the difference between your samples and your population. Okay, that is your delta or margin of error. What is the difference? Okay, if I'm searching that, okay, the correlation between body fat and taking diet high fat is 0.5. That is their population. Okay, my research, I confident that the difference is 0. I will get 0.6 or 0.7 because my instruments is very specific. Okay, so that is the difference between population and yours. So that is your delta. Okay, so delta, the smaller the difference specified, the more the number of subjects needed. Okay, sample size is inversely proportional to delta square. Can be reduced by increase your delta, but right into the risk of having the result of your statistic to be not significant significant. So if your delta is large, then your sample size will be very small. Okay. Right. That delta, excuse me. Okay. So effect size. Effect size and delta is like quite same, but sometimes delta is for the numbers that you need to include in your calculations. Effect size can be it can be many versions. Many versions uh, according to the test. There's many tests. Size for t-test is different than effect size for correlations, and for the comparing means is different. Okay, so this is what I mean by the difference of effect size. Okay, for standardized mean different. Okay, for those of you who want to do research that you want to compare uh, stat, groups, different group, right? Comparing group research, either treatment groups or naturally occurring groups. Okay, this is between two independent groups, treatment and maybe control. So inherently continuous construct, continuous outcome means. Okay, maybe you want to do research about comparing the group research, but you have the outcome is in categorical, in rate. Okay, this one is for continuous. Odds ratio is for categorical outcome, for rate. If you have rate, dichotomous construct. Okay, another one, maybe, maybe in your research, in your proposal, you have 5 specific objective. So I think maybe the number 1 is usually your descriptive statistic, right? To measure what? The level of hemoglobin. Number 2, to compare hemoglobin group between two independent group, or maybe between male and females. Okay, that one. Okay, number 2, you can use this one. Your effect size, you have to use this one. If you have comparing between two groups, independent groups. Okay, maybe number 3, to compare the percentage of hemoglobin, the hemoglobin deficiency between between age group. Okay, that one you have percentage. So you have 20% of females have hemoglobin deficiency. Okay, that one you have this categorical. So you can use odds ratio in your calculation, sample size. Okay, maybe the third one. Okay, the third one. To correlate between hemoglobin levels and intake of ferrum. So you have 2 variables. Okay, number 3, your calculations can use correlations coefficients. Okay, so you have 3 special objective. You can calculate 3 sample size, and the final one is the one that is the highest one. For example, objectives number 2, standardized mean difference. You calculate, you need 100. Okay, number 2, to calculate by using rate. Okay, you calculate by using odds ratio. You calculate, I only need 50. Okay, number 3, by using correlations. Calculate. I need only 80. So that means the first one is the highest, right? 100. So choose 100. So in your proposal, in your writing sample size, you can show that, okay, by using this is calculation, this calculation, this calculation. So we choose this one because it can cover all the objective in your research. So you can confident now. Okay. Alright, so proportions. Okay, proportions it is for prevalence rate. You don't compare, you can use proportions. Okay, standardized gain score. If you have before and after, so before and after, you have gain or change between two measurement points. Okay, so in the sample size, this is you need to know your alpha, your power, your and this one. There will be one column that you need to key in about the effect size. Okay, so if you want to study more, this 1 hour, 2 hours is not enough for me to explain everything about Cohen's. Okay, you can search for Cohen's effect size. Yeah, so the Cohen effect size is different for each test. For t-test is different, ANOVA is different. So this is one of the guideline. Cohen 92 says that the small effect size is 0.2, 0.5, the large is 0.8. This is for D, Cohen D effect size. Okay, I don't want to see this one. Okay, Z. Okay, this is for this is the summary of the Z values from the very large tables. Okay, this alpha, if you remember alpha, alpha is type 1 error. If you choose type 1 error of 0.95, okay, so your Z values for two-sided, we always use two-sided. So alpha 0.95, your Z will be 1.96. So 1.96. Boleh color tak ni, apa ni? Boleh color. Okay. Apa? Okay, boleh color sini. Okay. 1.96. Alamak, tulisan. Okay. Yeah, just remember this. Okay. If these lectures come in your exam, don't worry, you don't have to memorize. We give you all the tables. Okay. Okay, I start with the one. Okay. Calculating sample size for this large population for survey. For survey, okay. Single mean continuous. Okay, this is from Cochrane. N equal to Z times with this is sigma. This is not what. This is sigma. Sigma means standard deviation. Okay, this is standard. Go there. Okay. Deviation. Okay. This is sigma standard deviations. Tukar color lain lah. Color. Okay. This is your delta. This is your delta. Kena cari pen yang cantik lah. This is your delta. Okay. Sikit. Okay. So this is your delta. This is your sigma. Sigma. Mari tulis sigma sini. Sigma. Sigma is your standard deviation. Okay. So where do you want to find this? Okay, this value is okay. This is for if you want to do study about just continuous strata and single mean. That means I want to study about hemoglobin levels. Hemoglobin levels among females in Malaysia. So it's very broad. Very broad. You don't want to compare male and female. You don't want. I just want to know the study of females in Malaysia. Okay, so the first one is your Z value. Okay, your Z value. If you want to choose, okay, if you want to choose your alpha, 0.95 means your alpha is 5%. 5%. Alpha 5%. If you remember this curve, this curve, So this value, okay, this one, this is for two tails, okay, this is your rejection area. Mana ni? Where you go, mouse? Come back. Okay, this is your non-rejection area. This is non-rejection area. This is your rejection area. Your rejection area, you can choose this one 5%. 5% error, 5%. So for two tails, the 5% divide by 2. So this is for this one. Alright. Okay, what the meaning of this 5% is when you have 100 tests, you are not perfectly 100% true, correct. So there will be an error. There will be 5% error. We all make mistakes. We are not perfect. When you're doing your study, your research, there will be an error. So that 5% error is your alpha. So the majority will choose 5%. It will be, if you are very critical study, then you can choose 0.1%, that means 0.99. So, well, your Z is 1.96, okay, 1.96. So this one 1.96, okay. Time with what? Okay, time with standard deviation. Okay, this is from your literature review. Okay. Oh, mouse, where are you going? Okay, this is from your LR, literature review. Or maybe your first phase of your study. Or maybe from your pilot study. You can use that one. Okay. And your delta is from your own need. This one, so this one is coding. If you want to choose 10%, I want to choose 3% or 5%, is open to you. Okay. About the delta, okay, I said that it's open to you, but I'm giving you examples. If this is about simple systolic blood pressure. Okay, systolic blood pressure. Okay, you say, doctor, I don't know the effect size. How can I choose? I don't know what the meaning of the difference between sample population. Okay, take your brief. Okay, take one. Okay, maybe you can search for one population's mean. You search the population or any studies that are similar to you. Okay, the same variables. Okay, take that. Search for the mean and standard deviation. Search for mean and standard deviations. Okay, for example, systolic blood pressure. Okay, so the mean standard deviation is 120 plus minus 10 millimeter mercury. Okay, if I want to choose 10%, okay, so my effect size is 10% from the mean. So 10% times with your mean 120 equal to 12 millimeter mercury. Okay, that's mean 12 millimeter mercury from your mean, from your minus and plus. Minus will get 132, plus 120 plus 12 is 132. 120 minus 12, you got 108. Okay, so I use this this delta. Okay, this is delta. Okay, under the triangle. Okay, this is delta. Okay, I'm using my effect size 10%. My delta is 12. Okay, so I use this delta and this sigma 10 inside this formula. So I will get the value of n equal to 3. So I only need 3 subjects so that my result will be between 108 and 132 millimeter mercury. So it's very logic, because the range is very big. The range is 12 times 2, 24. The range is 24. It's very big. I only need 3%. I'm confident that my result will be between this range. Okay, so you want to choose 10%. Okay, alright, just need 3 subjects. Okay, however, you say that, okay, I don't want 10% lah, doctor. I want 5%. Okay, so 5%. Okay, 5% times with the mean. Okay, times with mean, same, time with mean, you will get 6 millimeter mercury. Okay, this is your another delta. Okay, delta. So your mean will be between plus minus 120 is 114 and 126. Okay, I'm using this delta and this sigma. Okay, this sigma. I put inside the calculations, and my calculation sample size is 11. Okay, so compared 3, it is larger. It's increased. Okay, I need 11 samples to make sure that my systolic blood pressure is between 114 to 126 millimeter mercury. So this is the scale. The range is smaller. 6, 12. So the range is smaller. 12 millimeter mercury. Alright, okay, then I said that I don't want 5%, I want it is more, the effect size is smaller. Okay. 3%, okay, when you are using 3%, okay, so the difference is between 3 plus minus 3.6. Okay, so you need 178, and to confidently have your result will be between these levels. So it shows the difference that the higher the effect size, the smaller your sample size. The smaller, higher effect size, smaller sample size. Macam mana ni? Macam ni lah kot. Smaller sample size. This is small, this is higher. Okay. Okay. Calculate this one. A researcher would like to know the average diastolic blood pressure for graduate students. It is estimated that the mean diastolic blood pressure for Malaysian youth is 80 millimeter mercury with standard deviation of 10 millimeter mercury. Okay, level of confidence wanted is 95%, and the estimate of accuracy is within 3 millimeter mercury. Okay, so I calculate the effect size that been used. Okay, this is examples by Prof. Baharudin. So I'm trying to calculate the effect size, because in these examples, they just write them within the accuracy. The estimate for accuracy is within 2 millimeter mercury. So the researchers knows that they need 2 millimeter mercury. They know this is their field, their work. So they know, okay, I want 2 millimeter mercury. So they don't have they don't have any reason why they want to use 2% or 10% or 15%. Okay, but for me, I just calculate for myself, and I did standard error. Okay, the sigma divide by the mean. Okay, you got 2.5%. Okay, the effect size to be using in this study is 2.5%, small. Okay, this is sigma. Standard deviation is sigma 10. Level of confidence wanted 95%. Okay, this is means your alpha is 0.05, and this when it right here level of confidence 95%, it is will automatically your alpha is 5%. 5% or 0.05. Will be automatically. If your level of confidence is at 99%, your alpha will be 1%. Will be parallel. Is this concurrent? Concurrent or parallel or will be automatic. Okay, so this means that your Z will be 1.96. 1.96. Okay. And this is your estimate of accuracy within 2 millimeter mercury, mean this is your delta. Okay, this is your sigma. This is your delta. This is your alpha. Easy. Can answer it already. 1.96 times with 10 square divided by 2 square. So this is your sample size. So what I can say is that I am 95% confident that by using this number of sample size, 96 samples, my result will be between plus minus 2 with the populations. Plus minus 2 from population is 78 to 82 millimeter mercury. Okay. Okay ke? Everybody still with me?
Doctor,
Yeah.
the formula,
Yeah.
Z, Z alpha means it's a two tail.
This one is for two tails.
So
So
you
when
don't
I
have
write,
to divide to two.
no,
Do we need
you don't have to divide into two. This is automatically your Z will be 1.96.
So if I'm using one tail, so I just use the other one.
Yeah. If you are using one tail, okay, use this one, 1.645.
But earlier on, you said we always use two-sided. Why should we say that we always use two-sided?
Because if in the SPSS, it is default two-sided.
Oh.
And in majority of the research is they want to do your hypothesis now is there is no difference. You read that there is
Unless the question mentioned clearly that it is either a superiority trial, something like that, is it?
Yeah, unless you said that this is more this is higher than
Okay.
or less than.
If not mentioned, we use two-sided in question exam.
Yeah,
Alright.
okay. It is very easy because in SPSS or any other statistical apps, they will be default as two-sided. Okay. Other than that, okay.
Hi doctor, I'm Shantini here.
Yes, Shantini.
I just want to know like how to know whether I need to use like which alpha, whether 0.90, 0.95 or 0.99. How to know?
Oh, okay. Have you look my lecture slide video lectures for last 2 weeks?
Yes doctor.
So I think I've right there. If your studies is very my major field, maybe they consume maybe 1 million studies. Okay, that one maybe you need 99%. Or it is about life, about if it's about life and death of the subjects. Okay, that one you need 99, maybe 99.9%, 99 or 99. But if your research is not include, maybe there's only injury, no, not about death or life. Okay, that one you can use 95%. So majority will use 95%. Okay.
Okay doctor, if my research topic is about red cell aluminization in hospital Selayang, so it's something like can cause death also. So
So maybe the one you need 99%. Is this about the measurement, right? The machines,
yeah, it's about race aluminization. So like if like frequent transfusion can cause like death too, because due to rate harmonization. So I need to use 99 or 95?
I think 99. But that one you can discuss with your supervisor. Maybe because he or she is very expert in your field. They will ask you if it is 99. So you have to choose that one, 99.
Okay, doctor. Thank you, doctor.
Welcome. All right, another. Do you want this or we can use others? Okay, this is the same another examples about fish. Fish. This one you want to study about fish. Okay, this is the length or inches of the fish. Okay, the mean length from the sample is 3.1 and standard deviations is 2.4. We wish to sample enough fish to achieve precision plus minus 25% of the mean with 95% certainty. Okay, this one they don't give the unit but the percentage. So what you have to do is same formula. Okay, so standard deviations is 2.4. This is standard deviations. Okay, standard deviations. Okay, this is the mean times with the percentage, the certainty percentage. The certainty percentage in here is 25%. Certainty percentage. To achieve precision plus minus 25%. Okay, this one. So this is your effect size. This is effect size. Means time with effect size. So this is your delta. Okay, so delta square 36.8. Okay, make sure if you calculate 36.8, there's no, you have to round up it to 37. If it is 36.2, also 37, 36.1, also 37. 36 point something, it have to be 37. Okay, so single proportions is okay, this one is if your research question is to study the prevalence, to study the rate, the proportions. Okay, this is the formula. Z square P in the bracket 1 minus P divided by delta square. Okay. If you don't know, say, I don't know. We have searched many journal. This is my the only first research that we have built. Okay. So you can use 0.5 for P. The maximum variations proportions for the population. Okay, so we put 0.5 here, 1 minus 0.5. Okay. Okay, you can use prevalence study. You can use this manual, Luanga and Lemon Shop. Okay. This one is examples for calculations. It is about smoking habit. Okay, it's known that 30% of Malaysian males smoke. Okay. Confidence level needed is 95%. Okay, confidence level is 95%. I nak tukar highlighter lah. Highlighter. Okay, researcher wants estimation to be accurate within 10%. Determine sample size needed. Okay, so this is going to be your delta. This is going to be your alpha 95. Okay, this is going to be your P value. Semua dah ada. Okay, so P plus minus 0.1. The N is Z. Okay, this is 1.96 because you want 95% confidence level. 1.96, 0.3 because 30%. 1 minus 0.3, 10%, so 0.1. So 80.64 means 81 sample size. So when I'm collect 81 81 sample size, I will 95% confidence that my samples percentage will be within plus minus 0.1. That is between 0. Okay, the percentage is 30%. Minus 1, 0.2 to 0. Plus 0.1. Plus 0.1 is 0.4. Okay, in my research, my result will be between this range. And I'm 95% confidence. So you have to search for 81 subject. Okay, this one if you don't know the proportions, you can use 0.5. Okay, so this is a comparing two groups means already 12 o'clock. I have 2 hours, right? Comparing two groups, okay, for independent groups. Okay. Independent groups means male and female. Okay, two different groups. Female or male, between control and intervention, between children and adults. This is all those independent groups. Okay, so in this formula, N1 equal to N2. Okay, 1 plus 2, this is the constant. Okay, constants, and then this is sigma pool. Because you have two groups, you have to pool, you have to combine the standard deviation from two groups, you combine. Okay, so this is the standard deviation pooled. Okay, this is your delta for independent group. Delta for independent group. Okay, this is square, this is square. Alright, so for the C value here, okay, is from this table. If you choose your alpha 5%, okay, your power 80%, you can use 80%, it's okay. 7.8. Your C is 7.8. For Shantini, yeah, so in Hospital Selayang, you want to use your alpha is 1%. Okay, if you want to higher than 80%, maybe 90%, okay, your C will be 14.9. So this is a summary for the C values. Okay, how to calculate your standard deviation pooled is from this formula. You must have, so in this case, in this manually calculated formula, all you need is your mean plus your mean plus minus standard deviations. Okay, and your N. Okay, so this is mean 1, standard deviation 1, and N1. Okay, for example, this is for male. Okay, apa tu? Okay, however for females, macam tu lagi. Is another one. Okay, mean 2 plus minus. Tak boleh lah macam tu. Okay, standard deviation. Sorry. Alamak, aku kena tukar. Aku tukar pen. Okay, standard deviation. Sorry alamak, conteng lagi. Standard deviation 2. Ni. And 2. And 2. So, in this calculation, don't look at that drawing, very bad. Okay. Standard deviations by using manually, you need mean. Okay, mean 1, mean 2, you need standard deviation 1, standard deviation 2, you need N1 and N2. If you have these 6 number, then you can calculate. You can calculate it correctly, precisely. Inside this formula, and you will get the number precisely and accurately number. But I think many of students come to me and say that in all the paper we cannot see these figures. They don't give us the mean and standard deviation, or the group is not different. We are new groups. So this is maybe you have to search more. If not, then it will be hard, quite not accurately as if you have this number. We have these figures. Okay, all right. So this is for dependent group. This is for before and after. You have your research, you doing your so your before and after interventions group. So this is two dependent groups. So the formula is quite simple. Just standard deviation 1 plus standard deviation 2 divided by 2. So the delta is mean 1 minus mean 2 divided by standard deviations. So in this formula, you don't need n value. Just standard deviation and mean. Okay. This is for comparing two proportions. You have C, P1, P2. Okay, all this. Also, you don't have to remember it. Okay. If you want to search for your proposal, just search any other in here. I get it from the FLACE 1981. Okay, this is the formula that this research statistician use. You can use this one. Okay. Nampak quite complex, but it's just simple. Okay. P1, if you have the figures, proportions of group 1, proportions of group 2, like this. Investigator wish to detect a rate of 0.25. This is for group proportions 2. If the observed this is the population one. The P1 is for populations 0.5. Investigator wish to have the population 2 is 0.25. Then delta is 0.5 minus 0.25, alpha 0.05, and power 0.9. C equal to 10.5. So you calculate sample size is 84 for each group. So total is 170. Still okay? Can we continue? Everybody? Are you still with me?
Do we need to remember all the formula, Doctor?
No, you don't have to. If it's inside the exam, we will give you all the formula. But you have to memorize what is the meaning of P, what is the meaning of sigma, the delta. That one you have to remember. But the formula itself, we will give you.
Doctor,
okay.
I have one question.
Yeah.
Your example just now, one question used the word of accuracy of 25, precision of 25%. I think the fish.
Fish too. Okay.
The other one is using but why the wording, the precision of 25%, why to get the delta you times with the mean? Is that the formula? How do I know that in the question the number given is not a direct delta?
Okay.
I must times with the mean first.
Okay, all right. Okay, first of all, okay, thank you for the questions. Good questions. Okay, first of all, this is two different calculations. One is for continuous data. Another one is for proportions. For continuous data, okay, your delta will be the unit. Your delta will be your unit. Okay, so if in these questions, the delta, they just give percentage, not unit. So you have to times your percentage with the unit, with the 3.1, with the mean, to 25% from the mean. Then you will get unit here. Okay. And okay, this one is direct because they give you the unit itself within 2 millimeter mercury. There's no within 10%, 2%, 5%. If I'm asking you, okay, I'm not giving you the 2 millimeter mercury, but I give you 2.5% here. Then you have 2.5% with the 80 millimeter mercury. You time with this millimeter mercury, then we will get the delta is 2 millimeter mercury. Okay. Is it clear?
Yes, thank
you. For continuous, the delta should be in unit, in the scale, in the continuous data. Okay. However, in these proportions, your delta is directly your percentage. This is directly percentage. Ada contoh. Okay, this one. 10%. So, your delta is 10%. 0.9 is 0.1. You don't have to times another times again. This is directly from the percentage. So, for proportions, remember for proportions, it's directly percentage, but your single continuous, it depends. But if they're given you a unit, they use that figures. If they're giving you the percentage, you have to times your percentage with the mean to get the value. Okay, is it clear?
Doctor, thank you.
Welcome. All right. Another, I think this one. Okay, so this one, this is the last one. After this, maybe we go to the Google Power. Okay, you need to do a research about health awareness among first year UKM FSK students. Okay, by using calculation, you need because this is for, okay, I write here, this is for known populations, okay, for survey, cross-sectional study. For cross-sectional study, if you are doing intervention study, experimental study, so this is this is not for the experimental study. This is not for the experimental study, or not for the interventions, or not for the, I think, case control also not. This is only for cross-sectional study. Okay, so for example, by using calculation, you need 320 subject, but the population for all first year students is only 200. This is just examples. Okay, all your FSK students are only 200, and your target population is FSK students. If you are using calculation, you need 300. So you cannot use the formula before this, but you have to use Kretschmer or Morgan formula. Okay, so significance levels 5%, degree of accuracy of 5%. Okay, so this formula, Kretschmer and Morgan, this is standard deviation. This is chi-square. This is chi-square. Not, you don't have to square it anymore. The value of chi-square for chi-square. Okay, this chi-square for alpha 0.05. Your chi-square is 3.84. Okay, so 3.84 is for alpha 5%. So this is your N is population, total populations. This is for proportions. Okay, if you don't have the proportion, you can insert here 0.5. So 0.5. So delta square is your percentage. Okay, percentage of delta maybe 5%, 10% it depends on you. Okay, so this is chi-square, same with this one, chi-square. All right. Okay. Okay, this is examples. Okay, 3.84 times with 200 times with 0.5, 1 minus 0.5. Okay, the delta 5% square. So 200 minus 1 plus 3.84 times with 0.5, 1 minus 0.5. So total sample is only 132. Okay. Okay, this is for multiple linear regressions. Okay, from Tabachnik and Fiedel 2013. Okay, this is terms of rules. This is simple calculations, but you can use G power to make it very specific, more specific than this one. This is just a terms of apa ya? Apa nak sebut? Okay, this is just general formula. Just general formula. Okay. Okay, for example, your predictors is 10. I have 10 predictors. Okay. And must be more than 50 plus 8 times with 10 is 80. So must be more than 130. Okay, so you have to be more than 130 samples for doing multiple linear regressions. Okay, this extra sample size, if you have the final calculations is not final yet. You have to add to plus with the dropout, maybe 10% or 20%. It depends. It depends from the your pilot study or your literature. If your literature say your research style is almost 20% dropout, okay, so your calculation also have to plus with 20% dropout. Okay. Okay. What to do if you don't have any choice about sample size? Okay, because not because of limited budget, because nowadays is the COVID-19 problem. It's hard for you to get samples face to face. You go to community, it's very hard. So that maybe okay, you have to do the quality. You have to search for because sample size is one of several quality characteristic. Okay, so other than this one, you have to do to make sure that your research have the quality. If you are taking samples through online, okay, how can you make sure that the samples answers there is the one that answer your questionnaire? It's not their parents, it's not their granddaughter, their grandson. You have to find the way that the method is you have the quality in it. How maybe you have to decide, okay, they have to open the Google Meet, they have to answer with the camera or some things that is can make sure that your quality of your research. Okay, so have you download this G-Power?
Yes, Doctor.
Yes, Doctor.
Yes. Okay, good. So this is this is quite easy actually. For our faculty, if you want to present, it is been faculty will accept the calculation by using the G-Power. Okay. Right here, okay, so you can have this this one. Actually, after you have finished your studies, calculating samples, okay, for example, okay, you in your proposal you say that you need 100 samples. Okay, so you do your study, collect your samples until 100 samples. And then suddenly your supervisor said, Chantini, okay, this is not enough. 100. I want you to collect more. 50, 150. You have to go and collect another samples. Okay. Actually, you have 100 samples. So you can calculate the mean, the standard deviations. Okay. And then you can ask the G power to calculate the power for you. This one, post hoc compute achieve power. They can calculate power for you. Okay, so you insert all the effect size is from here. The mean group 1. Change this highlighters. Okay, the mean group 1, because you have already done 100 samples, right? Okay, mean group 2. Okay, standard deviation. You can calculate this one. Okay, then you transfer to this effect size. Alpha is 0.05. Oh, okay. This one is not 100. Okay, 25 and 22. For example, you have that sample size. Okay, then you calculate. They will show you the power 0.8. Okay, 0.8 is the minimum power that is needed in any research. So you can say to your supervisor, okay, or you can write in your thesis to defend your thesis from your external examiner. Okay, this study have 80% power with this sample size. I don't need to increase my sample size. So this is very powerful in your proposal in this semester, and after you finish your research, after 2 or 3 years, you can use this G power to calculate your power. Okay, this is another programs, power and sample size calculation, but I don't use this. It's easy for me to use G power. In these power and sample size programs, they have this one. Maybe some of you will like to use this power of sample size, because type of study t-test, this is the word that they from here. This is the, I think, from here. I don't know, from the output. Okay, this is the way they write your results that you have to put in the report of your proposal. Okay, so about the 10%, 5%, okay, that one is I studied from this paper, so you can search this paper. If I found it, if I have that paper in with me, I can upload in you can folio. Okay, so now let us use G power. Okay. You still can look at my desktop, right? Mana G power saya? Right, this one. Okay, everybody, look at this. This. Okay. First of all, you have to look at this test family. Okay, so we have exact. Under exact is this one. Proportions. If you have proportions, Fisher exact test. Okay. If you want to do F test, okay, UNCOVA, ANOVA, MANOVA, multiple regressions. Okay, this one under F test. Okay, T test. Under T test we have correlations, bivariate regressions, the mean difference, two means, independence, Wilcoxon, Mann-Whitney test. That one under T test. The chi-square test. Okay, if you're doing goodness of fit test, different tests. Okay, there are so many tests here. Actually, me myself is not very expert in all the tests. So, wih, kucing ni. So I can give example easy examples for you after this for a few minutes. Yeah. Okay, it is a correlation tetrachoric. I don't know that one tetrachoric. Okay, so first you have to decide which test that you want to use. Another one, second is what statistical test that you want to choose. Okay, another one is this test of power analysis. Okay, as your proposal, of course, the priori compute required sample size. You want to calculate sample size. But after that, you want to calculate alpha power. This one, post hoc compute achieve power is after your research done. You want to calculate your power is from here. Okay, right. So I want to start with one examples. Mana? Which one? Which one? Which one? Okay. T-test. I want to do T-test. Okay, I want to do T-test. I want to do, let me open this. Okay, for example, BMI for group 1 is 21 plus minus 6, and for group 2 is 25 plus with 3. Okay, so I want to calculate, I want to do a research about one is for a supplement, another one is not without supplement. 21 and 25. This is the BMI. This is standard deviations. Okay, if I'm using the this formula in the manually, so I can use this this formula. I can use this formula, but I have to search for standard deviation pool and in delta pool. Okay, but for this I need another value for n. For n equal to maybe this one I get from the research, from paper, from journal, any journal. Okay, 35. Okay, so maybe this is from journal, so I can use these figures. I can put it in here. Okay, and standard deviation. So we have these figures, right? So I get these standard deviations in here, and mean 1 minus mean 2. So mean 1 minus mean 2, we have that one. And we can insert here, and I will get the sample size. Okay. However, by using the G power, okay, T-test, mean, 2 independent mean. Okay. Alright, so in here, okay, so tails 2. For those who want to use 1, you can change to 1, but in these examples, I use 2 tails. Okay, the effect size. Okay, this effect size. You cursor to that column, sometimes they will show you. Okay, this is for effect size D. The effect size D 0.2 means small, 0.5 mean medium, 0.8 mean large. Okay, so these figures from the research, from the journal. So I can write it in here. Mean 21, mean group 2, 20, deviation 6. Okay, standard deviation for group 2, 3. So calculate calculate and transfer to main windows. So here, main windows. Right, and then I calculate 0. Sorry, I tak tukar. Sorry. I want to calculate sample size. Okay, I calculate sample size. Same, okay, same. Okay, my power is 0.8. My allocation ratio, group 1 and group 2, I want equal. So I put it here, 1, 2, okay. Right, calculate. So what I need for group 1 is 24, group 2 is 24. Group 1 24, group 2 24. So this is quite accurate. Yeah, the power is 81%. If you want to change the so you will need more, 38 and 38. Total size 76. Okay. Another one. This is okay. Any questions? Okay.
Doctor,
Yeah.
I try to using based on your need, but why don't come out this output parameters value when I put the effect size and then power like that.
Okay.
Because
You click calculate here at the down here. You have to click that.
they determine, right? Is it? No.
Determine is what?
Calculate. Okay. Okay, now I can see now. Okay, thank you,
Yeah,
doctor.
congratulations. Okay. Any others
Okay.
have a problem?
I know it. That's all. Thank you.
Okay. All right. Okay. Another example for multiple linear regression. If you have you want to do multiple linear regressions. Calculate proportion. Calculate proportion. Proportion. I pun tak ingat sekejap. Calculate proportion. MLR. Mana MLR? Multiple linear. Is it this one? Oh no. There's so many. Sekejap, multiple linear regressions.
Hi, Doctor.
Yes.
Can you show example in logistic regression?
I'm not really familiar with that one. But I'm familiar if I'm doing repeated measures, big design, ANOVA, multiple regressions. Okay, but multiple linear logistic regression. Which one? Square, not chi-square. Okay. Before that, I will give you this this one. I will give you this G power manual. Okay, this power manual is I just download it from online. Okay, they show you how to do correlation, proportion difference, multiple regression, generate binomial, fixed effect ANOVA one way, multiple regression, correlations. Okay. Mann-Whitney, generic correlation, multiple logistic regression. This one. Logistic regression 67. So in here you can study at your own according to what your research questions, what's the specific objective that you want to do. So they will show you the effect size, small, medium, large. Okay, for example, I want to go to the logistic 67. but this one is multiple logistic. You want to do multiple logistic or binary logistic?
Binary logistic.
Binary logistic. Oh, there's so many formulas here. Okay, the G power provides two different types of procedures to estimate power. There's a single predictor X, a priori. Okay, you must have your odds ratio. The odds ratio values. You have the odds ratio value from the previous research?
What's the meaning of odds ratio?
Okay, in the logistic regressions results, they will give you the odds ratio. So that you can say in the by using logistic regressions, okay, these variables is 2 times according to the values of the odds ratio. This is this variables is 2 times highly risk for that dependent variables. So the value for each independent variable. Sorry. Bau kari. Diorang masak kari. Sorry. Wow, what is this? What is this? Okay. I just want to look for this logistic regression. Logistic regression. Effect size is super bad. Not from here, not from exact. Is it exact? Logistic regression. Okay, this odds ratio. Okay, if you want to know, you determine this odds ratio. If you have these figures from any journals, you search for journals. If in that journal shows you the result of odds ratio for that variables, you can include it here. These values. And then you can calculate others. The alpha is 0.05. The power is 0. You can choose 0.9, 0.8. Regression. I put the cursor. Yang tadi. Sorry, doctor. Your line is breaking.
Huh? What break?
Your line is breaking.
Alamak. So tak dengar I kena buka pintu balik. Tutup pintu tak boleh dengar. Okay. Alright. Boleh?
Okay,
Tutup pintu
doctor.
tadi. Tutup pintu bau kari lah. Batuk-batuk. Okay. This one. Okay, I try again. I'm searching for the clue, the hint. Okay. Effect size conventions. Okay. F square 0.02 means small, 0.15 mean medium, 0.35 mean large. Okay, so this if you don't have any research prior from any research that you can compare with, you can choose from this effect size convention. Okay, for me, I will choose medium. I will choose the medium, 0.15. I don't want to use the large one. I use medium or between medium and small. So this one, the medium is 0.15. Okay, so the power, alright, 0.8. Okay, if I have predictors of 10, for example, to predict your quality of life, you have your diet, you have your physical activity, you have your stress coping skill. For example, I have 10 variables to predict my quality of life. Okay, so number 10, number total predictors is 10, so I calculate. So I need 118. Okay, so this is different if I compare with my calculation from here. If I calculate from Tabachnik, mana Tabachnik? From Tabachnik and Fiddle's rules of thumbs, I need 104 10 predictors. But in these examples, for 10 predictors, with the power, the effect size, medium effect size, I need 118. So this is very specific compared to the formula. So you can, okay, if this one, I use this one if I say that I don't have any research to compare with. Okay, for example, I have my study, I have a journal, say that, okay, there they show the partial of R square. The partial of R square is maybe 0.2. So I calculate that one, 0.2, my effect size 0.25. I calculate, transfer to main window. I calculate again. I only need 75. So this is the benefit if you have your the standard that you can compare with. Standard, not standard you can compare with. If you have the journals, the populations or the journals that you can refer to. You can refer. So this be that journal will be going to be your reference. Then it will be, you don't have to collect 100, only 75. Okay, so from here, if you want to present, you can print screen this one, or you can click this one, save plot to copy. No, I nak copy je. Copy plot to clipboard. Go to this one. Okay, copy and paste. Kan senang. Okay, protocol. If you want to print this control copy. This also you can also put it in your proposal. Huh? Other than that, okay, this one calculate. Okay, if you click for XY plots, can draw plots. Okay, this one. This will show you that, okay, if you are using the power 0.8, total sample size 300, you need more than that. I think that's all I can share. I have another reference book. This is reference book. Do you want this?
Yes, please.
Yes. Yeah.
Yes, doctor.
Okay, I can put it in the UK folio. Show the confidence, statistical power. This another one. Let me show. Let me show it's adequate sample size in health studies. Let me show and yeah. Sorry, tutup dulu lah. Stop presenting. Okay. Anything to discuss?
Doctor,
Yeah.
is our faculty only accept G power, or we can just use any apps or software to show during the proposal presentation?
You can use others. No problem.
Okay.
What is it? What is this? What is the apps?
I'm thinking using the EpiCalc or the specific RCT calculator.
Boleh.
Hello, I cannot hear you.
Yes. Yeah.
I cannot hear you properly just now. What was it?
Yes, you can use the EpiCalc.
Okay. So we also we just need to print screen or just show all calculation back to our proposal, right? The exact calculation done.
Yeah, you print screen and then you have to explain. If you're using the effect size from where, what is your reference, what is your if it is to compare between two groups or to compare between before and after, that one you have to write it. What is your alpha, what is your power, that one you have to write.
And then one more thing, usually the power 0.8 or 80% power is okay enough for a power research, kan?
Yes.
But recently, when I refer to the recent research on my particular topic, I mean, most of the researcher now are using 0.9.
Okay, then yeah, for your studies, for your field, then you can use 0.9.
But it will make my sample a bit more, I mean, I need a bigger sample.
Yeah, yes, of course.
With the limitation nowadays, is it still okay or is it defendable if I'm still using 0.8? Doctor? Or 0.5?
See, okay. I'm not sure because of this COVID pandemic, right?
Yeah.
I'm not really sure. Maybe you can discuss with your supervisor that one.
All right. The same thing goes to the alpha, the error.
Yeah. Yeah. The error this according to your field.
Okay.
If many of the journals say that 0.5, then okay, you can use 0.5.
Thank you.
0.05. Okay. Okay, Sharifah. Other than that, alamak, recording. Okay,
okay. Oh, Quran attendance. Oh, okay. How we could choose the perfect number? Not small, not too big. Okay. The attendance. Saya rasa dah tanya jap sini. Is it the same one with previous? I don't know. Can be used? Can it be used? This is the same. You can use it. Okay. Okay, that's all from me.
Another one more question.
Yeah. Who is it?
Aziana, Doktor.
Aziana. Okay.
Yeah. Doktor, I just have one question. For example, our objective, we have 3 objectives. Okay, then we, based on the calculation, we have like, for example, 50, 60 and 70. So we do.
Then?
Okay. Addition.
Alamak, Yana. Tak dengar dah, terputus. Hello? Okay. Hello?
Hello, Doktor. Okay. For example, we have 3 objectives. Then, based on sample size calculation, for example, the first objective require 50. Second one 60 and third 70. For example, so it is advisable to take 70 kan? Bukan, it's not that we have to add on kan? Okay.
Oh tak. Take the highest one, 70.
Okay. Okay, thank you, Doktor.
Okay, welcome. Others? Ada lagi? Okay, Om Cik nak cakap ke? Tak ada? Okay, tak ada Okay, kalau tak ada, thank you very much everybody. Have a nice lunch. Okay, bye. Bye.
Thank you, Doktor.
Welcome.